We now discuss the solution of a problem from the section analysis, and this question is on sequences. The problem is limit n tends to infinity 1 by n of, in brackets, 1 plus square root of 2 plus the cubed root of 3 plus so on and so forth plus nth root of n. The four options are given to us. Option 1 is equal to 0. Option 2 is equal to 1. Option 3 is equal to 2. Option 4 does not exist. We have to find the limit n tends to infinity of this expression, this mathematical expression. Okay, the four options are given to us and we have to decide which one is true. Before getting into the discussion of the problem and its solution, we recall, let un be a sequence of positive terms. First, we recall Cauchy's first theorem on limits. If limit n tends to infinity un is L, then limit n tends to infinity of u1 plus u2 plus so on so forth plus un by whole by n is also equal to L. The second theorem on limits due to Cauchy is the following. If limit n tends to infinity un plus 1 by un exists and it is equal to L, then limit n tends to infinity un, its power 1 by n, so the nth root of un exists, and limit n tends to infinity of un to the power of 1 by n is equal to limit n tends to infinity of un plus 1 by un is equal to L. And these are two important theorems that we require for the discussion of the solution of the given problem. Now, we take limit n tends to infinity of 1 by n into 1 plus square root of 2 plus the cubed root of 3 plus so on and so forth plus nth root of n is equal to. Consider the sequence un where un is the nth root of n. So, we consider a sequence un where its nth term is the nth root of n. Now, limit n tends to infinity of 1 by n in brackets 1 plus square root of 2 plus cubed root of 3 plus so on so plus nth root of n is same as limit n tends to infinity 1 plus square root of 2 plus cubed root of 3 plus so on so forth plus nth root of n by n. And that is the limit n tends to infinity of u1 plus u2 plus un by n. Now, this will be equal to limit n tends to infinity of un if exists by Cauchy's first theorem on limits. Now, limit n tends to infinity of un is the nth root of n. That is, limit n tends to infinity n to the power of 1 by n if exists. It is well known from our intermediate classes that limit n tends to infinity of nth root of n is 1. Yes. So, therefore, let's look at our options, and our answer is option 2, because the limit of the given expression is equal to limit n tends to infinity of nth root of 1 by n, and that is 1. It is well known. Therefore, our answer is option 2. So, that is the discussion of the solution of that problem. For those of you who do not know this limit n tends to the nth root of n is equal to 1, I will show you that it is equal to 1 using the Cauchy's theorem, second theorem on limits. Let's do it in the next slide. We have limit n tends to infinity of 1 by n into 1 plus square root of 2 plus cube root of 3 plus so on and so forth plus nth root of n is equal to limit n tends to nth root of n, that is limit n tends to n to the power of 1 by n if exists. Up to that we have seen. Required to find limit n tends to nth root of 1 by n. Consider the sequence an where an is equal to n. By Cauchy's second theorem on limits, if limit n tends to an plus 1 by an exists and is equal to L, then limit n tends to an to the power of 1 by n exists and that limit is equal to L. Now, limit n tends to an plus 1 by an is equal to limit n tends to an plus 1 is n plus 1 because an is n by n. That is equal to limit n tends to 1 plus 1 by n and that is equal to 1. Therefore, limit n tends to an to the power of 1 by n, that is limit n tends to nth root of n, that is n to the power of 1 by n exists and it is equal to 1 by using the Cauchy's second theorem on limits. Thus, limit n tends to nth root of 1 by n is 1. And from 1, limit n tends to 1 by n into 1 plus square root of 2 plus the cube root of 3 plus so on so forth plus nth root of n is equal to limit n tends to n to the power of 1 by n and that is equal to 1. Let's look at our options and it is precisely the option 2. So our answer is option 2. So that is the discussion of the solution of the problem from the sequences. I am sure that you have understood the solution of this problem and go on working out to problems from the section sequences and series and their convergences. And that is very important. And now and then questions are coming on these lines. I wish you all the best. Thank you.